Okay, so number 4. So the amount of pollutants that are found in waterways near large cities is normally distributed with mean 9.5, standard deviation 1.5. 37 randomly selected large cities are studied. Round all answers to 4 places. Okay. So they start off and they're asking us for the distribution of X. So that's just going to be mean. You know, this N that they put right here means normally distributed with a mean, with a middle that's 9.5. So it's a bell curve, in other words, normally distributed bell curve whose mean, whose middle is 9.5 and whose standard deviation is 1.5. In other words, that's the average distance from the middle. That's what standard deviation means. The middle of the bell curve is 9.5, but not every city is completely average. Some are more or less polluted. The average distance from the middle is 1.5. Now, what's the distribution? What's the spread? What's the graph look like for X bar? Now, when they put the bar, now they're talking average down here. Distribution X bar, that's average. So it's going to have the same mean, but the standard deviation is 1.5 divided by the square root of n. And what's n? 37, right? There's my n. 37. So you got to, it changes the spread, right? When you talk about averages, then you have less spread. So I'm getting 0.2466. It's 5/9, so it rounds to 6. 2466. So when you're talking about a group average, averages are not so spread out, are they? There's less spread for a group average. Okay, and then coming on down to part C. What is the probability that one randomly selected city's waterway will have less than 10.3 parts per million pollutants? Less than 10.3. Okay. So you know what we're going to do? We're going to do the normal CDF. Maybe a better here. Let me slide it over again. Okay. Normally do. Come over here. Part C. So it's going to be, this is for n equals 1, isn't it? 1. See that? 1 randomly selected city. So that's going to be normal CDF. And we're going to have lower or left, upper or right, mean and standard. So what's the lower? Well, it'd probably be helpful to draw a bell curve. Let me do that. So we got our bell curve. The middle of the bell curve is the mean, 9.5. That means the average city has 9.5 is their pollutants. And the question being asked to us here is less than 10.3. So where's 10.3? 10.3 is bigger, huh? So it's going to be like over here, 10.3. And then they say less, and so that means they want the shading to go that way, don't they? Does everybody see that? Because that is less in that direction. Less is to the left, more is to the right, as you know. Okay, so there's the piece of shading we're talking about. Now, you know what we need to do the normal CDF. We need the left edge and the right edge. So here is the left edge. What is, right? That's the left edge of the shading. So the left edge of the shading, what is the left edge of the shading? Well, it's going to be negative infinity, basically. It goes negative, it goes left forever. Remember, it's like a number line. It's like a number line which has positive numbers to the right and negative numbers to the left. So if we go left forever, we're going to have negative, just put in a bunch of nines. And then right here, 10.3 is the right edge. This is the right edge right there. That's the right edge of the shading, I should say, right? So it's all about that piece of shading we're looking at. We're grabbing the left edge and the right edge of that chunk of shading. So the left edge, negative, I'm putting negative here. And remember, when you do a negative, it's got to have parentheses around it, right? Negative is parenthesis. It's down at the bottom of your calculator. Bottom of your calculator. That negative and then a bunch of nines. And then the right is 10.3. The mean is 9.5. Now, what are we going to put for the standard? Well, we're just going to simply put the 1.5. No dividing. Why not? Because n is 1 for part C, right? It's just one city. We're just grabbing one city. We're not grabbing a group. That's going to be part D when we grab a group. Questions I can answer on that so far? And then part D. Part D says it's the same exact thing. It's just a group, right? For 37 cities, the average. So n equals 37. They want to know what's the probability that the average for 37 cities, if they grab 37 cities, what's the chance their average will be less than 10.3 parts per million pollution? So again, we're going to do normal CDF. We're going to have to do lower or left edge, upper or right edge, mean and standard. So all these numbers are basically the same. The normal is negative. Oh, whoops, that's not the normal. That's the left edge, huh? The left edge is basically negative with a bunch of nines, right? You got to put that minus in parentheses. And bunch of nines there. And then the upper, the right, is still the 10.3. The mean is still 9.5. But here's the difference. The standard deviation is 1.5 divided by the square root of n, where n is 37. So that's the difference, right? For part D, we've got to divide by the square root of n because we have a big group. We have a group of 37. We're talking about the average for a group of 37. Like that. Okay, now let's come on down to part F. We're going to do Q1, Q3, IQR. Oh, wait, I skipped E, didn't I? I skipped E. So let's do part E right here. Is the assumption that the distribution is normal necessary? Is that a necessary assumption on this one? What do you think?
No.
Right. It's not necessary because why?
It's more than 30.
Yeah, exactly. So no is the answer on that one because it's more than 30, right? 37 is more than, right? We have 37 is our group size. So if you take a group bigger than 30, it's automatically going to be normally distributed. It's going to make the data spread out normally in a bell curve, the averages. The averages will have to. They'll have to spread that way in a normal curve automatically. So, so we're good on that. Now we come on down. Let's answer Q1, Q3, and the IQR. So what's Q1? You remember how to do these? Do them the same way we did them before. Q1, you're going to go to inverse norm. Whoops. Inverse norm. And you're going to go area left is 0.25. And mean and standard, the mean is still the 9.5. And now the standard is we got to divide, right? 1.5 divided by the square root of 37. And then for the Q3, it's the same thing, as you know. Inverse norm, and the area left is going to be 0.75. That's the only difference. And then finally, the IQR is Q3 minus Q1. Pop that in, and we've got it. And so there it is. Question 4. Anything I can answer on that one?